Hi, today I shall be developing regression model using R software, and this software is available online and it is free so far. You can download this software from online and here I have three variables. Such as GDP, import, and constant. Sorry, not constant, I call it consumption, CONS, and here GDP is the dependent variable. Okay, so my R software is here. I can develop is here. Just 1 minute. Okay, it is here. You can see this is the R software. You can see from here. It is the R software, and here I have to install packages. That means I shall have to write the program. So first I install, then packages, and the package name is lm test. Close, then bracket close, then enter. Okay, then you have to choose your location, find out your location, then press OK. So the whole things is being downloaded now gradually. Okay, it is set. Then I write library, then just 1 minute, make sure everything should be in order. So library lm test, enter. Okay, then my data and the location of my data, read CSV. My file is CSV file and it is located in the C drive under economics 4 folder, and the file name is reg1 and it is CSV in nature. Then bracket close, my data read C economics for reg1. Okay, then enter, then attach my data, okay. Then after that, okay, then now I want to see the data, right? So first I write my file name reg1. Okay, then I write read CSV, then file dot choose, right, bracket closed, comma, then header equal true, right? So that is my command to see the data, and so it is done. Enter. Okay, then my file is in the C drive. It is located in the C drive, economics 4, the folder name. I click on it and the file name is reg1. I click on it. Okay, so it is coming gradually. Okay, then I have to write my file name reg1, enter. So you can see my data year, cons, GDP, and import, and here GDP is the dependent variable and cons and IMP are the independent variable. Okay, now I set my dependent and independent variable that I set now. Okay, first I write y. Y means dependent variable, and our dependent variable is GDP. That means y can represent GDP. Enter. Then x can represent the independent variable, and I have two independent variables, import and consumption, right? So IMP and cons are the independent variable. Now model setting is done. Enter. Okay, now I shall run the regression model. So I write regression, then LM, then I write y is the dependent variable, then x is the independent variable. So I enter. Then I have to write summary of the regression model, right? So enter. You can see the result has come up. Residuals, right? Coefficients, estimate, IMP, consumption. Okay, here you can see estimate and standard error, t-value and p-value, right? So how to get this t-value or t-statistics? The formula is estimated coefficient divided by standard error. You can get the t-value, and it is the corresponding probability value. Suppose example 2916.66 divided by 26305.25 should be equal to 0.111. So that will always happen. The probability is how much? Probability is 91.4%. What about this one? 77.7%. What about this one? 52.7% probability. In this model, y is the dependent variable, and what does mean by y? GDP is the dependent variable, and import and consumption are the independent variable. Okay, first I check whether import is a significant variable to explain GDP or not. That we can check. And what is the probability? 77.7%, which is more than 5%. So import is not a significant variable to explain the GDP. So the guideline is, if the p-value is less than 5%, then corresponding independent variable is significant to explain the dependent variable. But if the p-value is more than 5%, then corresponding independent variable is not a significant variable to explain the dependent variable. Then what about cons? is it significant variable? The probability is 52.7%, which is more than 5%, meaning that cons is not a significant variable to explain the dependent variable, which is GDP. Okay, now what is happening? Import and cons both are not significant, and that is not a good sign. So we are not happy about the model. So normally, what is the guideline? The guideline is if majority of the independent variables are significant, then we say the model is good. But here none of the independent variable is significant, so we are not happy about this model. Okay, then I talk about other things, such as I talk about the R square value, which is 5.29%. What does it mean? It means that 5.29% variation in GDP can be explained by our two variables, such as import and cons jointly. That means only 5.29% fluctuation in GDP can be explained by two independent variables, that is IMP and cons jointly. That means these two independent variables has a very little influence on the GDP. So this model is not good. So normally we say if the R square value is more than 60%, then we say that model is a better fitted model or good fitted model. In other words, higher the R square value, better the model, better good fitted. But here bad fitted model, because only 5.29%. So we cannot accept this model. Okay, then I talk about F statistics. You can see F statistics and the corresponding probability. It is 80.43%. It means that F statistics is not significant because p-value is more than 5%, meaning that our two independent variables jointly are not significant to explain our dependent variable, which is GDP. So this model actually is not good because it has so many problems. Okay, now we check whether this model has serial correlation or not, or whether this model has heteroscedasticity problem or not. Okay, first I check whether this model has heteroscedasticity or not. That we check, meaning that I'm just showing one more thing. Just wait. I'm showing it. Okay, make it small slightly. Okay, I take it up. Okay, I make it little small. Just 1 minute. Okay. Okay, I make it slightly big. Okay, so that means my null hypothesis is there is residuals are homoscedastic, right? An alternative hypothesis, residuals are heteroscedastic. And here the null hypothesis is desirable for a good regression model, and alternative hypothesis is not desirable. And here I shall use the Bruch-Pagan test, right? Bruch-Pagan test, right? And so here I write the command to do it. BP, meaning that Bruch-Pagan test, then write regression, BP test regression. I did. Then enter. So you can see the result, studentized Bruch-Pagan test, and this one is the Bruch-Pagan statistics and corresponding p-value. What is the p-value? 66.92%, which is more than 5%, meaning that we cannot reject null hypothesis, rather we accept null hypothesis, meaning that residuals are homoscedastic, and that is desirable. So we are happy about the model because residuals are homoscedastic. So that is only the good sign of this model. Now we can check another one, whether this model has serial correlation or not. That we can do, and here I shall do the Bruch-Godfrey test, right? To do it, Bruch-Godfrey test, and the null hypothesis is there is no serial correlation in the residual. An alternative hypothesis is there is serial correlation in the residual, and here null is desirable for a model, and alternative is not a desirable thing. Okay, now I write the command bg test by y by this one x, right? So that is my command. I did it. Enter. You can see, okay, here I have done a mistake, so I have to write it in other way. I can write it better. Just 1 minute. Okay, now it is okay. So it is the bg test. You can see bg test result when the order up to 2, that means lag, when the lag is 1. When the lag is 1, then this result will come up, right? Lag 1. LM test is 1.5678 and probability is 21.05 when number of lag is 1. Okay, here p-value is 21.05%, which is more than 5%, meaning that we cannot reject null hypothesis, rather we accept null hypothesis, meaning that there is no serial correlation in this model. So we are happy about the model. There is no serial correlation. Okay, now I check if I take order 2 or lag 2, then what happens. So I write my comment. Sorry, there is no serial, so that is my comment. Okay, here I write the comment bg test as before y by x, y by x, then comma order 2, that means lag 2 in the model, then enter. You can see Bruce-Godfrey test for serial correlation order 2, that means lag 2. Here LM test, what is LM? Bruce-Godfrey Lagrangian multiplier test. Test statistics is 1.7, p-value is 42.61%, which is more than 5%. So we have to accept null hypothesis, meaning that there is no serial correlation. So we are happy about the model. Okay, now I check if I take order 4, then what happens? Order 4 means lag 4, right? Then what happens? Lag 4, I take it, enter. You can see lag 4. So LM test, and the p-value is 16.75, meaning that it is 16.75%, which is more than 5%, meaning that I cannot reject null hypothesis, meaning that there is no serial correlation. So we are happy about this model. This model has many problems, but it has only two good signs. Number one good sign, there is no heteroscedasticity, meaning that residuals are homoscedastic. We are happy about it. And number two, there is no serial correlation in this model. That is also another good sign. And thank you very much for being with me. Bye.